In this video, we use a Horner's scheme to find the roots of a polynomial which is of degree 3. We have this polynomial x cubed plus x squared minus x minus 1. And we want to find the roots of this polynomial using Horner's method. First of all, we have to identify the coefficients of this polynomial. Because the coefficient of x cubed is 1, the coefficient of x squared is 1. The coefficient of x is minus 1, and this is the constant term, minus 1. In order to start the Horner's method, we need an initial guess to find one root with a naked eye, and we add these coefficients first. Let's add these coefficients to see what we get. Get equal to the sum of the coefficients give you 0, and basically this means that if I put x equals 1, I get one solution of one of the solutions of the polynomial. Now the Horner's method works in this way. You take this number, you take it down, you write 1 here. 1 multiply with 1 gives you 1. You sum these numbers in a vertical direction, and you get 2. 2 times 1 gives you 2. Minus 1 plus 2 gives you 1. 1 times 1 gives you 1. You sum these numbers vertically, and you get 0. The polynomial can be written as x minus this root, minus 1, which was the initial guess, times this will be the coefficient of x squared plus the coefficient of x plus the constant term. You see that the polynomial that you get here is 1 degree less than the polynomial that you have here. This one can be written as x plus 1 to the power of 2 by this known identity. It's x squared plus 2x plus 1. So my polynomial is x minus 1 times x plus 1 squared. Which means that, of course, the one root is 1, and the other root you have to get x plus 1 equal to 0, and you get x equal to minus 1, which is a double root. So my roots, let's call it calligraphy R, are the following: minus 1 and 1. This Horner scheme is helpful because it helps you to factorize this kind of polynomials and find the roots. But the main drawback is that as you increase the degree of the polynomial, we know from Galois theory that it's very difficult and impossible to find the roots. And another drawback is that you have always to find what is an initial guess. One root with a naked eye, which means you need one root to start Horner's scheme, to use Horner's scheme. And once you find this obvious root, you impose Horner's scheme, and you can write it in a factorized way, your polynomial p of x, and then you get the two roots, 1 and minus 1 here, which is a double root.